Welcome to this video about exponential functions, explainingmaths.com. So far, as you can see on my website, we have done several types of graphs. First of all, linear functions, which are a line when you draw it. The highest power of x is 1. We've done quadratic functions, parabolas, the highest power of x is 2. Cubic functions, which is some sort of S figure. Reciprocal functions. And now, as you can see, exponential functions, which will always look roughly like this. Now perhaps again there's some sort of transformation, so if we include a negative, perhaps it gets reflected, or it goes up a few units, or to the left or to the right, but it will always look roughly like this. And what is an exponential function? Well, an exponential function is a function where x is in the exponent, so 2 to the power x. X is the index of your function. So please differentiate between x to the power 2, which is a quadratic function, and if you would graph it, a parabola, and the exponential function 2 to the power x, okay, which is an exponential function. Okay, now I just want to show you why it looks the way it does, okay, because then you will be able to understand all exponential functions in the future. So I'm going to make a table of values, and I'm just going to sketch that, guys. We're going to do that a little bit together. So this is not a beauty contest. I'm just making a table of values, a fishbone table as I sometimes call it, to show you an exponential function. Let's say x is 0. Okay, when x is 0, how much is y? Y equals 2 to the power 0. And when I was explaining the laws of indices, to the power 0, everything to the power 0 is 1, I show you there. So when x is 0, y is 1. So if I just that's 4, so a quarter of that, so that is going to be roughly there. My mark is quite thick, but you with a sharp pencil do a better job. Let's see, when x is 1, 2 to the power 1. Well, 2 to the power 1, that will be 2, agree? So half of 4 is going to be 2, so it's going up. What if x is 2? 2 to the power 2 is going to be 4. There we go. And when x is 3, 2 to the power 3, how much is that? 2 to the power 3. Who said 6? You're wrong. 2 times 2, 4 times 2 is 8. Don't make that silly mistake. Careful there. 3 and then 8. So as you can see, it is going up quite rapidly. It's going up quite exponentially, actually. 4, 2 to the power 4, 2 times 2, 4 times 2, 8 times 2, 16. Whoa, hang on a minute. That is going up super fast now, isn't it? 4, so that is 4, 8, 12, 16 over there. To the power 5, it's not even going to fit anymore. 32, 4, 8, 12, 16, 20. You see, it is already off the table. It is going up super quickly, And I always tell my class, if this is the time and this is my salary, then this is not the curve that represents it, unfortunately. My salary doesn't grow like that. I wish. Okay. But as you can see, the larger value you take for x, it just goes up significantly. As a rocket to the sky, it just shoots up. But what about the other side? What if I extend my table of values on this side for some negative values? Let's say when x is minus 1. Now 2 to the power minus 1. Now we can all put it in our calculator, and then it says half. But do you remember when I was doing the laws of the indices and I explained negative indices? What does a negative index mean? That is the same as 1 over 2 to the power 1, and I showed you why and how. I'm not going to do that again. So that's why it is a half. So when x is minus 1, y is going to be a half. And when x is minus 2, so 2 to the power minus 2, then y is going to be 1 over 2 to the power 2, which is a quarter. And with this thick marker, that's very difficult to plot. But I just want to show you that the y stays positive. When x is minus 3, y is going to be 2 to the power minus 3, that's 1 over 2 to the power 3, that's 1 over 8. You can see that? When x is minus 4, it's going to be 1 over 16. So if I now draw it, and I'm going to attempt to draw it because with these thick markers, it's not the easiest job. Alright, there we go. Yeah, that is my exponential function, where in this case it is approaching the x-axis, but it will never reach the x-axis. Even when x is minus 1000, then y is going to be 2 to the power minus 1000, which is 1 over 2 to the power 1000, which is like 1 over a trillion billion. But that's still positive. It's almost zero. Y is almost zero, but it's never going to be actually zero. You see that? So we call that an asymptote. It's approaching that line. It's approaching the line y equals zero, but it will never reach it. Okay? But on this side, it's shooting up the sky as a rocket. Okay. Exponential functions. I hope that was useful. Yeah, I have shown you now all the graphs, quadratics, cubics, reciprocals, exponential, linear functions. We have asked questions about those graphs, finding gradients. We've been solving by looking at graphs. So if this was useful, yeah, share this with your friends and like the video so I can help them too. Check my website, explainingmaths.com. You will find more resources there, all for free. And you can also ask me questions, guys, on the forum, and I will help you. I'll be very happy to do so. Okay, I wish you a very pleasant evening, and I'll see you later. Bye-bye.